Hi, my name is Derek Armson, and in this video I will be presenting my computer science project, or what I have of it so far. Originally, when I had first set out on this project, my idea was to create a game. But as I continued working on the game, I found working on the math side of it much more interesting than working on just the pure game design part of it. So I decided to just do more research into the math which makes games tick. So instead of going over everything I have in the game so far, which isn't very impressive, I'll just put it that way, I will be going in depth on the math of vectors. I'll give you a little thought experiment here. So say you have a triangle, an isosceles triangle, and the longest point of this triangle, that is the angle that the triangle is facing. So if you were to draw a line perpendicular to the base of the triangle and then have that line projected through the front heading of the triangle, and you are given just the center location of this triangle and the angle at which the triangle is facing, how do you draw this triangle mathematically when the angle can be variable? On a 2D plane, the triangle's vertices locations are arbitrary when you're just talking about x and y. Really, the only concrete thing you know about this triangle is the angle at which it's facing and the radius of the circle which this triangle is inscribed in. I had a lot of trouble visualizing the math behind rotating a shape like this until I just thought about the vertices of the triangle as being vertices on a circle, because then you only need the radius of that circle and the angle of the vertices, which are not changing. You can think about any point on this circle as being a possible point for the vertices dependent on the input angle at which the shape is turned. The only information you need to find the x and y values of these vertices is the radius and the angle. Once you stop thinking about the line that goes around the circle itself and just think about all the lines that go between the center of the circle and the outside of the circle, now you're thinking in vectors. Now suddenly it's not about x and y, it's about radius and angle. So in the image you can see here, the graph, you'll see a circle, and there is a point on the edge of that circle, which I can cycle between each point on the circle by just changing the angle. And then there's the radius slider, which changes the size of the circle. If you wanted to get an x and y value of the point on the circle, you just have to change the angle. So basically what my program does in terms of computing how the object should rotate and then be graphed is by just taking the baseline angles and relative locations of the vertices in relation to the center of the circle. And for each of those angles for each vertex, you just add the objective angle of the shape as it's being turned. So you'll see that for one point specifically here, you could just change the angle and it goes around the circle. And then if you just have multiple points along the circle, they will all be changing at the same rate as every other point on the circle. So this isn't necessarily an intuitive thing, but once you just think about it for a little bit and think about how the math and trigonometry works into it, then you can start to understand how to graph a shape and have that graph be interactive with rotational variables. And this isn't even getting into the velocity math and acceleration that is involved in the movement of the player. This is just drawing the player's shape. But yeah, this is just one system used in drawing the character's shape. And it took me about 10 hours just to figure out the math behind it and how I could go about solving that problem, because it's not necessarily intuitive. But if I just used a traditional video game creating platform, I wouldn't have any idea of this math because they would have already done it for me. And though the math might seem kind of pointless and boring, it's just a good thing to know about. And just having that intuitive understanding of this arbitrary principle and pattern here, you can use that in other places. Like just from this starting point of like getting an idea of how vectors work, I use that information and then I had a better idea of how to go about doing vector math on motion. and acceleration and velocities and all that. But beforehand, I had no idea what I was doing. I was just floundering about in the dark, and I feel like I have a much better understanding doing it this painful way. But I find the math behind the game much more interesting than the game itself. And I'm not making a good case for the game so far, but I do think it has good potential for cool game mechanics. It's just a matter of coming to the point where I intuitively understand all the systems that I'm trying to design. So yeah, thank you for watching.